Here we have a normal distribution, x, which is normally distributed with a mean of 120 and a variance which we don't know. We do know the probability that x is greater than 100 is 0.8621. We can use the symmetric nature of normal curves to draw this so that it will work with one-sided tables. Clearly, 140 is the symmetric point to the right. If we now sketch our normal, the area to the left of 140 must be the same as the area to the right of 100 on the original diagram. So the probability of x being less than 140 must be equal to 0.8621. Working with this expression, the probability of z being less than 140 take away the mean over the standard deviation, which we don't know, must be equal to 0.8621. If we look at our tables, we'll find that phi of 1.09 is equal to 0.8621. This means that 140 take away 120 over sigma must be equal to 1.09. So 20 over sigma is 1.09, and therefore sigma is equal to 20 divided by 1.09. Calculating this, we get that sigma is 18.35, correct to 2 decimal places.